investor, not financial advice.
Imagine waking up in August of 2036 and opening the SpaceX app. One screen shows thousands of active satellites moving data between Earth and orbit. Another shows a Starship leaving a coastal spaceport with cargo for the moon. A third shows compute workloads shifting between terrestrial data centers and machines in space. And somewhere on the same network, a robotic convoy may be preparing a landing zone on Mars. That future is possible. It is not promised. This episode is a speculation map, not a prediction disguised as news. We are going to start with the verified SpaceX of 2026, then build 3 versions of 2036. A floor case where the hardest technologies remain stubbornly difficult, a base case where launch, connectivity, and lunar logistics scale, and a breakout case where rapid reuse changes the economics of orbit. The central question is not whether SpaceX will still build rockets. It almost certainly will. The deeper question is whether rockets become only the first layer of a much larger company, one that sells transportation, connectivity, compute, national security infrastructure, and access to destinations beyond Earth. My base case answer is yes. By 2036, SpaceX may look less like a launch contractor and more like a vertically integrated infrastructure network. But the path runs through 5 gates: reliable Starship reuse, profitable global connectivity, economically useful orbital compute, repeatable lunar operations, and a Mars program disciplined enough to survive delays. We will test every one of those gates. And at the end, I will give you the version of SpaceX I believe is most plausible in 2036, along with the signals that would prove this thesis wrong. The best way to avoid science fiction storytelling is to anchor the scenario in what SpaceX has already built. In its second quarter of 2026, SpaceX reported $7.8 billion of revenue. Connectivity contributed about $4.3 billion. AI contributed about $2.6 billion, and the space segment contributed just under $1 billion. The company ended the quarter with roughly $100 billion in cash, cash equivalents, and marketable securities, plus $47.5 billion in backlog. Those figures matter because the 2036 company is already visible in miniature. Launch is the access layer. Starlink is the recurring network. AI is the capital-intensive compute layer. Government programs provide strategic demand. And the balance sheet gives SpaceX unusual room to fund several expensive bets at once. The operational baseline is equally important. SpaceX reported 78 launches and 1,041 metric tons delivered to orbit in the first half of 2026, primarily for its own connectivity network. Starlink reached 12 million subscribers by the end of June. Flight 13 deployed 20 production V3 satellites, demonstrated an in-space Raptor relight, and completed an intact heat shield splashdown. That is not full rapid reuse, but it is evidence that the vehicle is moving through real operational gates. Now the warning label. In the same 6-month period, SpaceX spent about $28.5 billion in capital expenditures, including $23.6 billion in the AI segment. The company still reported a net loss. Scale creates opportunity, but it also magnifies execution risk. So our starting point is neither a fantasy nor a finished machine. It is a company with extraordinary launch experience, a profitable connectivity segment, enormous capital, and several technologies that still have to prove their economics. The first gate is Starship. By 2036, the most important question may not be how many Starships exist. It may be whether SpaceX has turned each vehicle into a repeatable unit of transportation. SpaceX's investor materials describe the V3 architecture as a 100 metric ton class system and connect it directly to Starlink V3, mobile satellites, AI compute payloads, and interplanetary travel. But payload capacity alone does not create an airline-like network. The system needs predictable launch operations, safe recovery, fast inspection, manageable heat shield maintenance, reliable engines, propellant transfer, and regulatory approval at multiple sites. In the floor case, Starship becomes useful but not routine. It flies valuable heavy missions, yet refurbishment and launch site constraints keep cadence limited. Falcon remains important longer than expected, and some future markets stay too expensive. In the base case, Starship reaches high cadence without becoming literally as simple as an aircraft. SpaceX operates several launch and landing corridors, refurbishes vehicles on measured schedules, and uses most of the capacity for its own satellites, government missions, lunar cargo, and large commercial payloads. The competitive advantage is not a magical launch price. It is the ability to coordinate factory output, launch slots, satellites, software, and customers inside one system. The breakout case requires something harder: full and rapid reuse at a cadence high enough to make orbit an industrial destination. If that happens, SpaceX does not merely win launch contracts. It controls the freight railroad that feeds its own communications and compute platforms. My base case does not assume hundreds of passenger flights or daily Mars departures by 2036. It assumes a highly productive heavy-lift network whose internal missions matter more than the external launch market. That alone would reshape the economics of space. The second gate is connectivity. And this may be the most durable part of the 2036 story. Starlink had 12 million subscribers at the end of the second quarter of 2026. The company also reported a large and growing enterprise and government business. Its final prospectus said dedicated mobile satellites were already serving millions of monthly unique devices across roughly 30 countries, and the FCC authorized SpaceX to operate up to 15,000 Gen 2 satellites worldwide, subject to the conditions of its order. By 2036, the realistic opportunity is larger than home broadband. Starlink could be a connection layer for aircraft, ships, farms, emergency response, remote industry, military systems, autonomous machines, and ordinary phones outside terrestrial coverage. The terminal may become less visible even as the network becomes more important. The floor case is still a substantial business, tens of millions of users, but lower prices, stronger competition, spectrum limits, and rising replacement costs restrain margins. The base case is a global hybrid network. Terrestrial carriers handle dense cities. Starlink fills mobility, resilience, rural coverage, and direct-to-device gaps. SpaceX earns revenue through consumer subscriptions, enterprise contracts, government services, and mobile network partnerships. The breakout case is that satellite connectivity becomes a default feature inside billions of devices and machines. But that outcome is not simply a satellite count race. SpaceX must manage orbital congestion, debris risk, spectrum coordination, replacement cycles, local regulation, and public trust. My 2036 base case is that Starlink remains the economic flywheel. It funds the launch system, creates demand for new satellites, and gives SpaceX a recurring relationship with customers. Rockets make the network possible. The network makes the rockets strategically valuable. The third gate is orbital artificial intelligence, and this is where the scenario becomes both fascinating and dangerous. SpaceX's prospectus says the company wants to extend compute infrastructure into space and identifies potential orbital AI deployment as early as 2028. It also warns that the required technologies are complex, unproven, capital-intensive, and may never become commercially viable. That warning should shape the 2036 forecast. Space offers abundant sunlight and direct proximity to satellites generating data, but it does not eliminate physics. Computing hardware still needs power conversion, radiation tolerance, thermal control, networking, repair strategies, and replacement. Launch costs can fall dramatically without becoming irrelevant, and many workloads are cheaper to run near terrestrial power, cooling, technicians, and fiber. The floor case is a series of demonstrations that never beat Earth economics. The base case is narrower and more plausible. Specialized inference, Earth observation processing, autonomous spacecraft operations, secure government workloads, and data reduction before information is sent to the ground. In this version, orbital compute complements terrestrial data centers rather than replacing them. The breakout case requires SpaceX to combine cheap-lift, mass-produced compute satellites, vast solar arrays, laser networking, and automated fleet management into a commercial platform. If it works, the company's launch, satellite, and AI divisions reinforce one another in a way competitors may struggle to copy. But investors should not value that breakout today as if it were already an operating utility. In the first half of 2026, SpaceX spent more than $23 billion of capital in its AI segment. By 2036, the decisive metric will not be satellites launched. It will be useful compute delivered per dollar after power, cooling, networking, failures, and replacement are included. The fourth gate is the moon. This is where a 10-year horizon can be genuinely transformational without requiring a permanent lunar city. NASA selected SpaceX's Starship human landing system for the first Artemis lunar landing and requires an uncrewed demonstration before astronauts use the vehicle. NASA is also pursuing multiple lander providers for later missions. That competition matters because a real lunar economy needs more than one mission, one customer, or one transportation system. The schedule is not guaranteed. NASA's Inspector General reported in March 2026 that lander development challenges would delay planned Artemis dates and highlighted unresolved safety and rescue concerns. That is exactly why this episode uses scenarios instead of calendar promises. In the floor case, SpaceX completes major lunar demonstrations, but missions remain rare, expensive, and government-led. In the base case, Starship becomes one of several recurring cargo and crew transportation systems serving lunar science, power, communications, surface mobility, and early infrastructure. SpaceX does not need to own every lunar business. It benefits if each one needs transport and bandwidth. There is already a small clue in that direction. NASA selected Starlink mini laser terminals to support high-bandwidth imagery from Orion. By 2036, a cislunar communications layer could connect spacecraft, surface assets, and Earth, even if the full architecture evolves differently from today's plans. The breakout case adds fuel production, large-scale construction, and private industrial activity. That remains highly speculative. My base case is simpler. The moon becomes a recurring logistics destination, not a mass-market settlement. If SpaceX can turn heroic one-off missions into repeatable service, that would be a historic business achievement by itself. The fifth gate is Mars, and this is where honesty matters most. SpaceX was created to make life multiplanetary. Starship's size, reusability, and in-space operations are designed around that ambition. But a launch vehicle is only one part of a Mars system. The company must also solve long-duration life support, surface power, radiation exposure, landing heavy payloads in a thin atmosphere, communications delay, maintenance without a supply chain, and return propellant production. In the floor case, no crew reaches Mars by 2036. SpaceX still makes progress through robotic cargo, communications demonstrations, Earth orbit propellant transfer, and surface system testing. That would be a delay, not necessarily a failure of the broader company. The base case is regular uncrewed Mars missions that pre-position power, communications, supplies, and autonomous equipment. SpaceX may attempt a crewed expedition only after the cargo system proves it can land accurately and support a return plan. I would not make a self-sustaining city part of a responsible 2036 base case. The breakout case is the first crewed Starship mission reaching Mars before the end of this 10-year window. Even then, the accurate description would be an expedition or early outpost, not a city and not an independent civilization. Mars may therefore be strategically important before it is financially important. It forces SpaceX to develop closed-loop systems, autonomous operations, extreme reliability, power, manufacturing, and communications. Some of those capabilities can create value in Earth orbit and on the Moon long before they support a settlement. By 2036, the strongest evidence of real Mars progress will not be a rendering or a date. It will be cargo landed, systems operating through a full cycle, propellant technologies demonstrated, and a credible safety case for humans. So where will SpaceX be in 2036? My base case is a company with 4 connected layers. First, a high-cadence Starship freight network supported by a smaller set of specialized legacy vehicles and partner systems. Second, a global Starlink broadband and mobile platform serving consumers, enterprises, governments, vehicles, and machines. Third, a mixed terrestrial and orbital compute business with space-based hardware focused on workloads that genuinely benefit from being in orbit. Fourth, a cislunar logistics business supporting repeat lunar missions while a mostly robotic Mars architecture matures. The breakout case is much larger. SpaceX becomes the dominant transport, communications, and compute operating system for Earth orbit, establishes a meaningful commercial lunar supply chain, and sends the first crewed expedition to Mars. The floor case still matters. Starship cadence stays constrained, AI spending destroys more value than it creates, regulators limit constellation growth, competitors erode pricing, Artemis slips, and Mars remains beyond the horizon. SpaceX could still be a formidable company in that outcome, but not the integrated infrastructure empire implied by the bull case. Watch 5 signals. 1. Actual Starship reflights and refurbishment time. 2. Starlink subscriber growth, ARPU, replacement costs, and mobile adoption. 3. Orbital compute revenue, not demonstration launches. 4. Repeat lunar cargo and crew missions after the first landing. 5. Capital discipline, especially whether cash-generating connectivity can support AI and interplanetary programs without permanently overwhelming returns. The most important idea is this. In 2026, SpaceX uses rockets to build businesses. By 2036, those businesses may determine where the rockets fly. This is scenario analysis, not financial advice. Which future do you think is most likely? The floor, the base case, or the breakout? Tell me below and subscribe to SpaceXInvestor for the next checkpoint.